Hello 8th graders, this is a conservation of momentum instructional video for extra support. So if you're watching this video, I'm going to go briefly through a couple of practice questions. The first things that you need to know are that this whole premise is based on the fact that all the momentum before a crash is always going to be equal to all of the momentum after a crash. And in order to solve momentum, momentum is mass times velocity. So if you have the mass and velocity of two different objects and they're hitting each other, you can figure out any missing variables, and that's what we're going to work on. So here's the first practice problem. In this situation, a pool ball with a mass of 0.8 kilograms is rolling across a table towards another ball that is at rest. The first ball hits the second one at a velocity of 4 meters per second, and if the second ball has a mass of 0.6 and the first ball comes to a stop after the impact, how fast does the second ball go? So this sounds like a lot of complicated information. Let's break it down one piece at a time. I'm going to use 3 different colors in order to represent the before, the after, and for the totals. So the first thing that we're going to do is the before momentum. So what we're going to do is we're going to make a table that looks like this, and we're going to keep track of all of our information this way. So for the before for ball 1, we're going to call ball 1 the pool ball that was rolling to begin with, and it said in the question that it had a mass of 0.8 and is rolling across the table towards another ball at rest. We need to find a velocity. The first ball, it's the second one at a velocity of 4. There it is. So we're going to go back down to the before, and it's mass times velocity. Remember, we're solving for momentum in this box. So the mass was 0.8, the velocity was 4, and when you do 0.8 times 4, you get 3.2. Okay, so we found the momentum for the first ball. Let's talk about the second ball. It said that it's rolling across the table towards another ball that is at rest. That translates to 0, so we have a velocity. If the second ball has a mass of 0.6, so we have a mass, we have a velocity. So 0.6 times 0. Anything times 0 is 0. So we've got the momentums for all the things before. Now I'm going to switch colors in order to talk about all the momentums after. So in this question, it doesn't say whether or not the ball's lost any mass, so we're going to assume that they're the same mass of ball. So the first one has a mass of 0.8 still, and we have to look for a velocity. So it says, where's the table, first ball hits the second ball, if the second ball has a mass. So it says the first ball comes to a stop, so the first ball is going to be at rest when we're done, so anything times 0 is 0. And then we go back to the problem. It said that the mass of the second ball was 0.6. That shouldn't have changed. And it doesn't say how fast the second one's going. In fact, it says how fast is it going right there. So we don't know. So we have to assign a variable. And I like to assign the letter v so that when we're done, we know what kind of variable we're looking for, and it's the velocity for the second ball. So 0.6 times v2 is 0.6 v2. Now, I'm going to grab my third color in order to show the last step, and that's where we take all of the before momentum, and we're going to add them together, so that's a big plus sign there. All the before momentum is 3.2 plus 0, that's just 3.2, and we have to figure out all the after momentum, so that's 0 plus, that's a big plus sign, plus 0.6 v2, and that's just 0.6 v2. And then we just set them equal to each other. So 3.2 is equal to 0.6 v2, and then it's just an algebra problem. In order to solve this, we have to divide both sides by 0.6. We go to our calculator, and we go 3.2 divided by 0.6, and we get 5.3. So the velocity of our second ball was 5.3. Don't forget units, we did velocity, so that's meters per second. So I want to show you a second one. This one, if you have objects that are moving in opposite directions, that means that they're going to have opposite signs for their velocity. You can't have a negative mass, remember that. But if you have something that's going to the left, and it's going to hit something that's already moving to the right, they're moving in opposite directions, so one of them has to have a positive velocity, the other has to have a negative velocity. Let me show you what I mean. So in this kind of a problem, 2 football players are running right at each other. Player A has a mass of 60 kilograms and is running to the right at 2 meters per second. Player B has a mass of 90 kilograms. When they collide, they move together toward the left at 0.5 meters per second. How fast was B moving before the hit? So just like the last one, we're going to set up a before and an after table just like that. and we are going to start plugging in what we know. So I'm going to grab my first color again, and we're looking for player A before. So it says two players are running towards each other, right at each other. Player A has a mass of 60 and is running to the right at 2 meters per second. Now I'm going to just arbitrarily decide that going to the right is going to be a positive number. I could have picked it the other way, but I've just decided that the right's going to be positive. You can make it either way and you'll still get a correct answer. That's just what I chose. So this is going to be a positive 2. So 60 kilograms running 2 meters to the right. Fill it in my before chart. 60 is the mass, times 2 is the velocity. That's 120 for that player's momentum for the before part. Then it says player B has a mass of 90 kilograms when they collide. We don't know the moving before the hit, that's what we're solving for, so we don't know the before velocity. So we're going to have to use a variable. So it says player B is moving at has a mass of 90. Now, this is where I sometimes see a mistake. We know that this is going to be a negative velocity because player B was moving in the opposite direction, but we're not going to make the variable negative because when we solve for it, we know that it should work out to be a negative number when we solve. So right now we're just going to leave it variable. So we're going to say velocity for player B, 90 times VB is 90 VB. Now we're going to go to the after, so I'm going to grab my other color, and for after, we're going to assume that the players have the same mass. So player 1 should still have a mass of 60 kilograms. Now we're looking for velocity, and this is where we have to be really careful. It says when they collide, they move together toward the left at 0.5 meters per second. Remember, we said that towards the right was a positive number. So when they hit each other, they're going to be moving in a negative direction according to what we decided at the beginning. So mass is 60 times a negative 0.5 because they're moving to the left together. 60 times negative 0.5 is going to be negative 30. Player B, on the other hand, still has the same mass, and they're moving together, so they have the same velocity, negative 0.5. That's negative 45 when you multiply it out. Now the last step, same as the last problem. We've got to combine all the stuff before, so 120 plus 90 VB is 120 plus 90 VB. And we have to set it all equal to the other side. So negative 30 and negative 45 together is going to be negative 75. And then we just have an algebra problem. So I'm going to subtract 120 from both sides to get rid of this 120 over here. So minus 120, minus 120. And I'm left with 90 VB on this side. And that's going to equal negative 195. Then you just have to divide by 90. Divide by 90. And we will get VB equals, and then we go to our calculator. We've got to do negative 195 divided by 90, and that's going to equal negative 2.2 if I'm rounding. Don't forget units, meters per second. So that was the velocity of our football player before the hit.